Right. Welcome, everybody, to your free GMAT Prep Hour. It is February 7th, 2024. My name is Reed Arnold. As always, if you're looking for other free options, please know that we have them. You can take the first class of any of our GMAT courses, no charge. That is 1/9 of the entire package, and you might as well go. We talk about some big stuff in class one. We're going to talk about how the test works. We're going to talk about data sufficiency, and we're going to talk about some really big stuff in critical reasoning. So even if you have no intention of taking the course, you might as well go and sit in class one for no charge. You can do a similar thing with our interactive and our on-demand courses, see what our online package looks like. And there's also the free Foundations of Math workshops twice a month, or sometimes more, but certainly twice a month. We're going to hold 2 workshops, one on variables, one on computations. You can kind of think about it as like the foundations of algebra and the foundations of arithmetic. So basically dealing with how to do math with numbers and then how to do math with unknown numbers. We've separated those into 2 5-hour sessions, really free of charge. Come attend them. Sativia, who's here today, has been to both of them. I hope she will attest to how awesome they are. But I think it's a great place to start. And even if you honestly, I learned things. I have a math degree and I taught the GMAT for years, and I learned things coming to these Foundations of Math workshops and learning how to teach them. So even if you feel pretty strong on the math, I think they're a good place to stop in. Pick up just some new tricks on how to do math quickly and accurately for this test. So today, what we're going to do, it's kind of in the Twitch the GMAT series that we've started. So if you look in our library, you have videos of me taking the old version of the GMAT, which is now discontinued as of this week. And then Ryan recently took the GMAT Focus. And so what you can watch is us take a test and do problems and talk through what we're noticing, when we're noticing it, how we solve, et cetera, et cetera, et cetera. Students tend to like that. They've liked those videos. So I figured I would do something similar with the official questions that the GMAT has offered in their study starter kit. So what I'm going to do today is I'm going to go through the problem-solving questions that are, for free of charge for anyone who's going to take the GMAT. They have access to these. There's 19 problem-solving questions. I'm going to do those problem-solving questions and kind of just tell you what I'm doing. Now, I want to be clear that the way I do it is not the only way to do these questions. And I would encourage you to find as many ways to do these questions as you can when you're studying. I think it's very valuable to find different paths through quant problems because it just builds your toolkit out. But I'm just going to show you what I notice, what I'm doing, what I'm thinking as I do these questions that are meant to be kind of like the first sample of what GMAT quant looks like. So without further ado, I'm just going to jump into that. I've set up the slide here so that it pulls up the questions. There are 19 of these. Again, these are all just the free questions at MBA.com. Everyone has access to them. They're free of charge. If you're going to study for the GMAT, you get this practice this set of practice questions. I think there's about 70, and you get 2 free practice tests, which will have all sorts of other questions added. So let's just show you what I notice as I go through GMAT quant problems. So if y equals x minus 3 squared, then y is least when x equals what? So this is in the category of functions to some degree, right? I have an equation that I have an output y given different inputs x. I plug in x, I get a y, right? And I'm asked when y is least. So I want to minimize this value. And I want to know what x value lets me minimize this value. And I want to just emphasize here, notice how much I'm picking apart the question and really specifying what my goal is before I do any math. This is really a thinking test and an organization of thought test before it is a math test or a reading test, quite frankly. So I'm going to think about what values of x get me the smallest value of y. Well, another thing I'm noticing is that this right here, x minus 3 squared, right? That even exponent is going to make this, any even exponent, a squared, take a to the power of 2. It's going to be greater than 0 unless a itself is 0. But a squared cannot be negative. That's just something I'm on the lookout. I just know even powers can't result in a negative number on the GMAT because we don't allow imaginary numbers on this test. And so I see that this x minus 3 squared can only be 0 or above. And what am I doing to that number? Well, I'm taking some number, squaring it, and then adding 4. So some number that's positive plus 4 equals y. Or I'm sorry, I should say positive or 0 maybe, because that's going to be important. Equals y. And I want y to be as small as possible. Well, I want this number to be as small as possible. And this number is smallest at 0. Well, what x value makes it 0, right? Because this number is not x, it's x minus 3. Well, that is 0 when x is 3. Okay. When x is 3, x minus 3 is 0. 0 squared is 0 plus 4 is 4. And that gives me the smallest possible y. So I got that one correct. Fantastic. Let's take a look at this next question. Company X has 50 employees and company Y has 60 employees. Both companies have the same number of full-time employees. Okay, so I'm just going to stop. I'm going to stop and think about this. I'm going to organize my information. X has 50, Y has 60, and they have the same number of full-times. But Y has 3 more. Oh man, this is tricky. Y has 3 more than twice the number of part-times X has. Oh man, okay. And I want to know how many part-time Y is part-time. So I'm thinking about what I could do here. You know, it's funny. I think this is listed as an easy question. I don't think this is particularly easy. Um, I'm thinking about what I could do here, and I feel like I could set up some equations, some algebra equations, and solve. Sativia, you've been to some of my classes. What is my opinion about setting up algebra equations? Don't do it unless I have to. That's right. Okay, I'm very cautious of algebra. I want to know how to do it, and I am practiced in it, so I can do it if I have to. I took an official GMAT a few weeks ago, and I definitely used some algebra. But I'm actually thinking this might be a chance to do some back solving. Okay, these answers give me the possible values of y, of y's part-time. And what I recognize there is that, okay, if I know y is part-time, Sativia, I've told you this, but I wouldn't expect you to remember it, but I'll tell everyone else now. A really good sign of back solving as a strategic option is that plugging in an answer lets me infer other values in the question pretty easily. And so since these answers represent y's part-time, I recognize pretty quickly that I can get x's part-time because it's the same. Those are supposed to be the same number. I'm sorry, that's not true. They have the same full-time. Don't make that mistake. But I can definitely get y's total because I know y has 60. So for instance, let's just run this here, right? If it's 3, 7, 14, 17, and 20, and it needs to add to 60, right? Well, this will be y is full-time. It will be 57, 53, 46, um, 14, 3, 7, 14, 43, and 40. And since these are the same as x is full-time, which then can tell me x is total. And that's going to be, I need to get to 50 from these. Well, first off, these two answers don't make sense because x only has 50 employees. Excuse me, this shouldn't be x's total. This should be x's part-time. I need to add to 50 to get to x to get to x's total. So 46 plus 4 is 50, 43 plus 7 is 50. We're sorry, but Firefox is glitching. That's not very nice. Where's my mouse? Here. And then I need to check this last thing, that y has 3 more than twice of x's part-time. So I need to multiply x's part-time and compare that to y's part-time. 2 times 4 is 8, plus 3 is not 14. 2 times 7 is 14, plus 3 is 17, so this has to be the answer. So I would choose D. Okay. I could have set up equations, but I really felt like, hey, if I just plug in y's part-time, I can get y's full-time. When I know y's full-time, I know x is full-time. And when I know x is full-time, I know x is part-time. And then I can check the relationship that they've given me with this 3 more than twice the number. Okay. I'm sure there's an algebra approach. It might even be fine, but I just try to avoid it. And I like back solving, and I like setting up a table to back solve. I think if I organize my information first, and notice, like, I just did it all at once. Some people that like fret, like, oh, which one should I start with? If the numbers are easy enough, and these are pretty easy, I just do it all. I say, okay, here's y's part-time. This would be y's full-time. This would be x's part-time. You know, just add to 60. Okay, then add to 50. Okay, then move on. I like back solving. Okay. If a is a positive integer, and if the unit digit of a squared is 9, and the unit digit of a plus 1 squared is 4, what is the unit digit of a plus 2 squared? All right, so one thing that, if with some time studying for the GMAT, you might learn is that there's a pattern to the units digit of exponents, right? So for instance, you tell me that a squared is 9. Well, I know that numbers that end in 3, right? If I put them to the first power, they end in a 3. Okay, organize this. Yeah, first, second, third, fourth power. To the first power, that number is going to end in a 3. To the second power, that number is going to end in a 9. To the third power, that ends in a 7. To the fourth power, it ends in a 1, and then it goes back to 3. What other number has a 9 when you square it? It's going to be 7. To the 1, it ends in a 7. To the square, it ends in a 9. When you cube, it's going to end in a 3. And when you raise to the fourth, it ends in a 1. And then you go back to the fifth, it's going to start again at the 7. These are the only 2 numbers, the only 2 digits that when you square end on a 9. Okay. And then it tells me a plus 1 squared is 4. The unit digit of a plus 1 squared is 4. Well, okay, if a ends in a 3, a plus 1 is going to end in a 4. 7 plus 1 would end in an 8. And if I square those, 4 squared ends in a 6, 8 squared ends in a 4. It's got to be this. So I know I'm in the 7s. So I want to know the unit digits of 7 plus 2 squared. Well, that's 9, something that ends in a 9 squared. That's going to end in a 1. So I'm going to say 1. Okay. If snow accumulation increased at a constant rate of 30 millimeters per hour. Okay, so I'm kind of curious. It looks like I'm going to do a unit conversion. How many seconds did it take to for snow accumulation increase by 1 millimeter? Okay, well, this is a kind of ratio rate question. 4 millimeters, we're still in millimeters. 4 millimeters in 1 hour. I'm sorry, 30 millimeters in 1 hour. That's 30 millimeters in 60 minutes. So that's 1 millimeter in 2 minutes. And that's 120 seconds. So that's my answer. It's a unit rate conversion problem. Okay. 3,600 employees at company X, a third are clerical. And then we reduce that clerical staff by a third. So let's do 3,600. A third of them is 1,200 are clerical. We reduce that number by a third. So this is going to become 800 because a third of 1200 is 400. What percent of the total number of remaining employees would be clerical? Well, I want to be careful here because I can already see that the trap would be to be 800 over 3600, but it would actually be 800 over 3200 because we've taken 400 employees away from the total as well as from the 1200. So that's going to be 25%. Okay, now you might, I don't know if maybe you thought about this or maybe you didn't. You might be like, well, okay, but hold up. You told me you reduced the clerical staff by a third. What happened to the other? How do I know the other staff didn't also reduce? They would tell you, right? If I just know, if they just tell me the clerical staff were reduced by a third and they don't tell me any other changes, just there were no other changes, right? You don't have to worry about that situation. All right. X squared equals 2y cubed and 2y equals 4. Well, that just tells me y is 2. If 2y is 4, y is 2. So x squared equals 2 times 2 cubed, which is going to be 2 times 8. So x squared is going to be 16. And 16 plus 2 is 18. Seems straightforward enough. Almost seems too easy. So if this were the test, I'd probably take a second to double check this. I feel pretty good about it, but this is one of those things where, middle of the test, it's like, don't miss easy points. If you feel like someone was easy, just double check it real quick before you move on, because the ones you really can get are the ones that are worth the most points. Hard questions are not worth as much on the GMAT as easy questions. And so if a question feels easy, there might be a trick that you don't want to step into, but make sure you get the points for that easy question. So y is 2. I definitely feel good about that. 2 cubed is 8 times 2 is 16. I definitely feel good about that. So yeah, 16 plus 2. Okay, great. There you go. Sad fractions. 1 over 1 plus 1 over 2 plus a third. Okay, well, look, I could do some fraction math here, but I don't want to. What I'm noticing first off is that this is going to be greater than 1. So I have 1 over something greater than 1. Well, that tells me I can't have a number, right? This 1 over greater than 1 is less than 1. Doesn't matter what that denominator is, as long as it's bigger than 1, this is a fraction that's less than 1. So these two are out because it's not less than 1. Now, I wonder if I can figure out how much, what are we going to be at here? So this is 1 over, okay, well, this little fraction here is a little bit less than a half. So, this is approximately 1 over 1 plus a half, which is going to be 1 over 1.5, which is 2/3. So I feel like my answer should be about 2/3. 6/7 is too big. 6/7 is like 80, but it's like 0.86 or something. That's too big. 3/10 is too small. It's going to be 7/10. That's about 2/3. Okay, so I just could have done my fraction math, but it just bums me out. Okay, 1/2 the money in a fund is in stocks, 1/4 in bonds, 1/5 in a mutual fund, and the remaining 10,000 is the government certificate. So how much is in what was the total amount of the trust fund? So we are looking for the total, keeping track what's being asked, because they could have asked for the stocks, the bonds, the mutual fund, whatever, right? It's a half, a fourth, a fifth. And I could get a common denominator, or I could say that's 50% plus 25% plus 20%. That's 95%. Fractions tend to be better for multiplication and division, and percents tend to be better for addition and subtraction. So I know that 95% is this stuff, and then 5% of my total is going to be $10,000. That's the remaining 10,000, which is 5%. Well, to get to 100%, I multiply everything by 20. And so my total is going to be 20 times 10,000, which is 200,000. So this value is going to be 200,000. There we go. Okay. The Earth traveled around the sun at 18.5 miles per second, and I want miles per hour. So again, we're in a unit conversion question. Miles doesn't change, it's just miles per hour. So 18.5 miles per second is how many miles per hour? Well, eventually you just 60 times 60. If you do this enough, you just remember that there's 3,600 seconds in an hour. So I need to multiply 18.5 times 3,600, not 3,660, 3,600 is going to be my answer. That's how many miles per hour. And let's just see if some of these, right, these don't make sense. That doesn't make sense. It's going to be one of these. So 18.5 times 3,600. So I'm going to say 20 times 3,600 equals 72,000 minus 1.5 times 3,600. And that's going to be 5,400. So I need my number to end in a 600, and that's going to be D. Notice how I didn't do the math. Okay. And by the way, that move that I did here, we talk about stuff like that in the foundations of math, right? I don't have a calculator for this section. I should have emphasized that. You don't get a calculator for the problem solving. So how are you going to do 18.5 times 3,600? You have a few options, but I decided to do, well, turn 18.5 into 20 minus 1.5 times 3,600, because 20 times 3,600 I can do pretty easily. And 1.5 times 3,600 I can do pretty easily, because that 1.5 is 1.5. So 1.5 of 3,600 is going to be 5,400, because half is 1,800. So I just add a half on top, right? All these little mechanical moves, I've got some habits that make them fast, make them fast and accurate. And again, the foundations of math class are a great place to see that in action and to learn that for yourself. That, by the way, that move I just did is one I would not have done if I did not teach and learn how to teach the foundations of math class. That's the kind of math that I wasn't familiar with even, but I found very helpful for, here you go, just like that. Okay, table above shows the results of a recent school board election in which the candidate with a higher, I gotta read this again. Notice what I just did. Sorry, this was the purpose of doing this though. I was reading, but I wasn't thinking. You got to be aware that that's happening to yourself. It's going to happen to everybody. You're going to read words, but you have to notice, but you're not actually processing them. It's even in math, it's certainly in reading comp, but even in math, stop, notice, reread. Hold up, you're not actually engaged. Okay, so let me re-engage. Table above shows the results of a school board election. Okay, so percent of votes, number of votes for P and Q. Okay. In which the candidate with the higher total number of votes from the 5 districts was declared the winner. So whoever had the most votes wins. And I see that, okay, we have, 60% of 800, 40% of 800, 50% of 1,000, 50% of 1,000, 40% of 8. Okay, so I see that we get percents of each district. And I know one of them won. And I want to know which district had the greatest number of votes for the winner. Okay, so there's 2 things I got to figure out here, is that which person won, and then figure out which district had the most votes for that person. Now, I know immediately one thing I could do is just figure everything out. I could just do, okay, 60% of 800 and 40% of 800, and 50% of 1,000 and 50% of 1,000. But I want to see if I can just notice some things before that. So first thing, I'm noticing that these were a tie. So they got the same number of votes from both of these. So whatever that number is, it doesn't really matter to who won because it's a tie. So whatever. I see that candidate P won the smallest district. Got 60% of 800, but that's not very many, especially compared to this 1,800. This is the biggest district. And I'm noticing that candidate Q won the bigger districts by a pretty substantial margin. So I already know candidate Q won. I don't need to calculate who had what votes. Candidate Q won. I like this question a lot, by the way. This is a really good GMAT problem. Because I'm like, the school book way is to do math. And one thing, Sativa, you've heard me say it a million times, Schoolwork math is neat and good, and you have it if you need it, but I try to avoid it. Algebra, whatever it is, just like anything that feels like grinding through schoolwork math, it's there, but I try to avoid it. Quantitative reasoning, learning how to do that is a better GMAT skill. So I already know that, okay, Q1, because they got a bigger percentage of this more populated districts. And I want to know which one they got the most from. And I'm pretty sure 60% of 1800 is going to be more than 70% of 1200. So 60% of 1800, well, 50% is 900, plus 10% is going to be 180. And so that's going to be 1080. And 70% of this is going to be like 800. And so it's got to be District 4. There we go. All right, let's moving on. A rabbit on a controlled diet. Oh, this is from the old, this is a reused question. So a rabbit eats 300 grams from 2 foods. I've done this one, so I do know this one kind of well. I think it's been on other free GMAT prep hours, quite frankly, but I'll show you how I would reason through it today. 300 grams of 2 foods, food X and Y. Food X contains 10% of a protein, and food Y is 15%. So food Y has more protein per ounce, whatever. And we have total is 38 grams. Of protein. So 38 of the 300 grams is protein from this X and Y. So what I'm going to do here is I'm going to figure out, okay, well, 38 grams of protein out of 300 is 38 over 3 out of 100. And 38 over 3 is 12, 24, 36. It's going to be 12 and then 2/3. So 12.67%. So my rabbit is in the range of 10 to 15%, is almost right in the middle. 12.5 is the middle. It's a little bit closer to Y. So my rabbit's diet is a little bit more Y to end up at 12 and 2/3% or 12.7%. And I want to know how much is X. So if Y is a little bit more than half, X is a little bit less than half, it's got to be B. 100 is too far away. And again, I'm sure I could set up equations and solve. In fact, I know I can because I've taught this problem using that, but I'd rather not. A box contains 100 balls from 1 to 100. 3 balls are selected with replacement from the box. So we select a ball and we put it back in. It's important to note. What is the probability that the sum of the 3 balls selected from the box will be odd? Okay. Well, what are the options? We can have odd, 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 even, even, or odd, even, odd. Or we could have even, even, odd, even, or even, odd, odd. These are the 8 possible outcomes. Each one seems equally likely to me because there's, yeah, we replace the balls each time. Again, that's an important distinction here. So when is the sum odd? Odd plus odd plus odd, that's going to be odd. Odd plus even is even. Odd plus even, that's going to be odd. Odd plus even, that's going to be even. Even, odd, odd, even. So it looks like 4 out of 8 or 1/2. 1/2 of the time we are, yep. Exponent stuff. Okay, 2 to the x times 2 to the y equals 8. Well, exponent rules. That's 2 to the x plus y. and 8 is 2 cubed. So that tells me that x plus y is 3. I know x plus y is 3 from that first piece of information. Now you're telling me 9 to the x times 3 to the y is 81. Well, 9 to the x is 3 to the 2x. Times 3 to the y, I can just add y to the exponent, equals 81 is 3 to the 4th. So this tells me 2x plus y is 4. And it's asking me what the values of x and y are basically. So I don't know. I think I'm going to multiply this by 2 and say 2x plus 2y is 6. That's just multiplying this by 2. And now I'm going to subtract 2x minus 2x is 0x. Y minus 2y is negative y. 4 minus 6 is negative 2. So y is going to be 2. X is going to be 1. So I need 1, 2. Here we go. Exponent rules mixed with some algebra. That felt a little classroomy. I could have back solved on that one, now that I'm thinking about it. You know, you could have plugged in, okay, 2 to the 1 times 2 squared is 8. 9 to the 1 times 3 squared is 81. You know, if I just plugged in A, it would have worked. But I did algebra that time. A certain bakery has 6 employees. Pays 14,000 to 2, 16,000 to 1, and 17 to the remaining 3. So the average is closest to which of the following? Closest always makes me think that estimation is allowed. Yeah, okay, let's just, okay, the sum is going to be 2 times 14,000 plus 2 times 16,000 plus 3 times 17,000. And I'm dividing by 6. So that's going to be 28 plus 32 is 60 plus 51. It's 101 over 6. Not my favorite math to do. Oh. So that's 9. And this is another move from our foundation to math. That's 90 plus 6 plus 5 over 6. I like to split my numerator into multiples of 6. 6 times, I should have this memorized, 6 times 15 is 90, plus 1, plus 5 over 6. So this means 16 and 5/6,000 is my answer, which is 16 and, I've done something wrong. Hmm. 32, 28, that's 60 plus 51. That's 101. That's 111. 60 plus 51 is not 101. It's 111. So, aha. Let's just, okay, so here's something fun. So I just need to add 11. I need to add another 6 and a 5. So that's plus a 1, plus a 5/6, plus another 5/6. This is a silly way to fix it, but it's going to be 17 and wait, this doesn't even work. This makes it even worse. Well, here you go, friends. Reed is making a silly mistake on what is definitely an easy question. Were this the test? Well, I don't know what I'd do. It depends how much time I had. I'd probably, if I was running out of time, I'd guess and move on. But since it's not the test, let's see where I messed up. 2 times 14, 2 times 16. Oh. There's only one employee that makes 16,000. 14,000 to 2, 16,000 to 1. Yeah, there you go. Read. See, we all make silly mistakes. Okay. 2 times 14 is 28, plus 16 is 44, plus 51. 44 plus 51 is 95. Oh man. Divided by 6. So that's going to be 90 plus 5, 6. That equals 15, 5, 6. Oh man. Whew. Silly mistakes. They'll cost you. Organize your information accurately, not quickly. Double check it. Make sure you don't do silly things like that. But also, hey, we all do it. Okay, 2s is greater than 8, so s is greater than 4. 3t is less than 9, so t is less than 3. Which of the following could be the value of s minus t? Okay, so could we get -1 from this? No, we could not. In fact, I'm kind of thinking we can get none of them. 4 minus 3 equals 1. And this is the absolute smallest s can be, and it really can't be this. And 3 is the absolute biggest this can be, and it actually can't be this. And so 1 is the maximum. And it's not really even a maximum because it's not allowed. It's the absolute limit that's not allowed. And so all these others are not possible. So it has to be none. Car traveling at a constant speed took 1 minute, 48 seconds to travel the distance between a certain roadside and the beginning of a road work area. So we have sign to work. And it took 1 minute and 48 seconds. That's 108 seconds. 108 seconds to make this journey. The distance was 2,400 meters. Then the car was traveling at what speed in kilometers per hour? So we know they went 2,400 meters in 108 seconds. But I want this to be kilometers per hour. Well, that's going to be 2.4 kilometers. In 108 seconds. And I'm actually noticing that 204 and 108 are both divisible by 12. So that's going to be 200 meters in 11 seconds. Okay, so that's 0.2 kilometers. Well, let's just do that times 3,600 seconds in an hour. And then there's 1 kilometer is 1,000 meters. Okay, so cross off 2 zeros, cross off 1 0. So I'm left with 20 times 36. Does that make sense? Divided by 11. At what speed in kilometers per hour? I feel like I made a mistake because this isn't working out as nicely as I thought it would. Yeah, Sativa is right. This should be 9 seconds, not 11 seconds. 108 divided by 12 is 9. Thank you. Yeah, 36 over 9 is 4. That's much better. 80. Good catch, Sativia. Again, we all make silly mistakes. 200. Let's also just take a second though. Okay, because I was not that far off, and this will happen in the test. right? I had to do some zeros canceled, right? So it was 20. I was dealing with 20 times 36 over 11. And none of my answers actually worked. But I knew whatever mistake I made, I was quite confident it was small. And so I should be pretty close. And what I can realize here is that, okay, 20 over 11 is about 2 times 36. So I need an answer to be about 72. And so that puts me to here and here, then, okay, I'd choose between those two. And that's a 50-50, So there is ways, even if you make a silly mistake, if you feel like your math was generally good, but something isn't quite working out, there's a pretty good chance that your mistake was small enough that it got you close. And then you can make an estimate and move on. Committee of 3 people is to be selected from 5 married couples, the dreaded combinatorics. Everyone hates these. Okay, so we want the committee. So we have 10 people, and we need the committee to not have the 2 married people. And we want to know how many choices we have. Well, okay. What I'm thinking is that let's choose the couples first, right? Because really we're taking a representation from 3 couples. So let's do 5, choose 3, which gives me 5 times 4 over 2, which is going to be 10. So there's 10 choices of the couples that we're going to choose, the 3 couples we're going to choose. And then from each couple, we can choose 2 people. So we have times 2 times 2 times 2 choices, which leaves me to 80. Think about another way you could do that. You could do, we have 10 choices for the first person, and then we have 8 choices for the second person because we can't choose this person's spouse. And then we have 6 choices for the third person, which gets me to 480. And how would I end up at 80 from that? I need to find a way to divide by 6. Why would I divide by 6? I think because that doesn't take into account that order doesn't matter, maybe. So you could divide by 3 factorial. I don't feel great about that. Ignore what I just said. Combinatorics, man, they're always tricky. If x over y is 2/3, then x minus y over x equals what? Well, x minus y over x is going to be x over x minus y over x. X over x is 1. Y over x is 3/2. So it's going to be negative a half. Straightforward enough. Functions. F of x is 2 to the x minus 3. And f of x is 31. 2 to the x minus 3 is 31. Means 2 to the x is 34. Now that's not a power of 2, but I know that 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is 64. So I must be between 5 and 6 because 34 is between those 2 numbers. So it must be between 5 and 6. All right, there we go. There are the 19 free problem-solving questions that come with the official Focus Starter Kit. That is how I would do them, including some silly mistakes. Again, I would review those and find other ways. I'd rather you find 3 ways to do a question than to do 3 questions. But I want to pinpoint a few things. Okay, first is that I generally avoided classroom math if I could. That's kind of a big one. I tried to step back and understand the situation first and do as much reasoning as I could. Sometimes I did classroom math. There's no doubt about it. But there are definitely times where I didn't. Okay, and you want to be aware of that and you want to study for that. I tell my classes all the time, the more the work you do on a problem looks like something you would have done in math class, the more likely you should review that question thoroughly, even if you get it right. That's great. And you want to build up your math skills. If you do a question and you don't do it the math class way and you get it right, maybe practice the math class way because you want that on your arsenal as well. But in general, I try to avoid it. Notice the variety of topics. Okay, it was a pretty good representation of some big GMAT problem solving stuff. Anything that you all noticed? Notice how many times I said that, come to our foundations of math class. What I'm doing here is I used come to them. They're great. They really change how you do arithmetic, and I find it very, very helpful. Anything you all noticed in how I solve these questions that might open your eyes to something about this test? So conversions, do you need to know certain conversions? You need to know like seconds to minutes and minutes to hours, 60, 60 seconds a minute, 60 minutes an hour. Other than that, I think they're going to give you the conversions. They're going to tell you how many meters in a kilometer, how many centimeters in a meter, how many, I think they give you how many inches in a foot and how many feet in a yard. They certainly give you how many feet in a mile. So I think by and large, the conversions are going to be given, except for the very hardest or the very easiest, like seconds and hours, seconds and minutes, minutes and hours. Anything else we noticed in the work here? Anything else we take away? Sometimes students remark that when someone who teaches this test for a living does problems, they note how quickly we recognize what's going on. And that's just pattern recognition. That's just knowing how the test tests certain things and how the test gives certain information. And when you're first studying, when you're first jumping into the GMAT, it's tough to do. But keep it in mind as a long-term goal that more and more when you do a question, not always, but very often, it should remind you of another question. You should see something like, oh, this reminds me of this other concept, or this reminds me of that question I did that one time. You should start to see familiar things in questions that trigger certain responses and certain organization and certain strategies. Okay. So that's just a repetition game, but also an active attempt at building a network of problems you've done before. Is there a list of common math concepts we should know? Yeah, list is a tricky thing, Justin, but I mean, pick up our book, All the Quant, called All the Quant. It gives you, everything you need conceptually to get the score that you're looking for, almost certainly. So I will do this again with the other question types. I'll do a data sufficiency. I will do a data insights. I'll do a critical reasoning, and I'll do a reading column. I don't know when I'll do these. It might be the next, might be over the course of a year. But I'll just do all the free problems that the GMAT gives to prepare for the test and show you how I would handle them. And you can try them yourselves and find as many ways as you can. But I look forward to seeing you at the next free prep hour. And I'm not saying that every free prep hour is going to be this. I might come up with a different concept and really want to teach that. But eventually we'll have all of these out there. We'll have a version for each question type on the test. If you're looking for those other free options, remember what I listed here. Come to our foundations course, come to our first class of any class, online or in person. We'd love to see you. I'll stick around in this room here to answer any final questions. Otherwise, see you next time. Good luck in your studies.